Maybe works. No. Oh, it works.
Oh, it works. Great. Great. Thank you, Artem. So I'm Pavel. I'm responsible in Yandex self-driving project for hardware, for quality assurance, and for the product. And today I would like to talk about these topics a little bit. So let's start. Let's start about the hardware. Artem said about the sensors which we use. You can see here the roof which we developed. It's our custom developed sensor box. We use 3 lidars, 6 cameras. You can see them here, and 6 radars which are under the bumper. So a little bit in details how these sensors see the world. This is about the cameras, 6 cameras, and so we think that this positioning is optimal for the perceiving the world. First of all, so let's talk about why we need cameras. We need cameras to detect traffic lights, to detect pedestrians, to detect cars around us, everything. So we need 360 view, and distance should be 200 meters. So this positioning and intersections between different cameras help us to detect pedestrians on one sensor, on another sensor, and track them when the pedestrian, for example, change the position. So let's continue. Let's talk about other sensors which we use. We use radars, 6 radars which we are positioned under the front bumper, the back bumper, and right and left. So any ideas why we would like to position radars like this? Because so you see here some white spots, and so maybe any ideas why we don't use any other positioning? So about front radars, it's easier, just because we would like to follow the cars in front of us. The back radars, it's also about the, for example, merging or lane changing. What about the radars on the left hand and right?
First you have cameras, second you have lidars probably. So probably this information is not necessary for your algorithm?
Yes, but we have radars which we position like this, on the right, on the left. So maybe, so it's really small car. Actually, it's under the bumper, somewhere.
But you've got wheels.
Here?
You've got wheels blocking it. You couldn't put it in the other blind spots because you have wheels in the way if you're putting it on the bottom.
No, the wheels, it's actually not a problem. So we put it here, just because of the crossroads. In Russia, it's really difficult. Like in an example which Artem showed us, you have to just a little bit push our car in the front, and then even the driver can see what's happening to the right. Radars can see it in 100 or 200 meters, and it's really easy. It's really helpful. So let's continue with the lidar. We definitely need to see what's around us, to see 100 meters around us in details, really accurate information with accuracy something about 3 or 5 centimeters. So that's why, so here lidars help us. But So you see here there are three sensors, three type of sensors, 6 lidars, 6 cameras, 3 lidars. What will be the next really difficult problem if you have so many sensors? So almost 15 different sensors of the car. What will be the next issue for the developer?
Fusion.
In addition, yeah, fusion,
Sensor fusion. Correlation.
computation, and fusion. What about fusion? So to fuse this data, you would like to know that this pixel of the camera is this point from the lidar and this point from the radar, for example. So you need to calibrate all the sensors together and synchronize.
Question.
Why
Yes.
do you need the radar if you have a lidar?
Good question. So, first of all, about the radars. Here you can see the distance. Actually, here about 100 meters. In real radars, you can see more than 200 meters. And radar provide you really helpful information. For example, speed of the objects. And so it's really helpful, useful. And for redundancy, you have to use all kinds of sensors to know what's happening around you. Let's return to the synchronization and calibration. It's a funny video how our quality assurance showed us that everything calibrate good. You can see here points from the image, which is the same. So it's a reprojection lidar points to the picture, and even objects move fast. The points are the same, in the same position. It works great, and without this information, it's absolutely impossible to know, for example, the distance to the object and know where is it. So I will not dive in details how to calibrate and synchronize sensors. There are many articles about this, but it's a really important topic which we should know.
Pavel,
Yes.
what about microphones and ultrasonic sensors?
About ultrasonics, actually, if you have lidar, which costs something about thousands of dollars, you don't need any ultrasonic sensor because you have enough information from lidar. Another problem with ultrasonic is accuracy. So you just get information about that something around, for example, 10, 20 centimeters accuracy, and the distance of the ultrasonics from 4 to 12 meters, for example. Tesla uses some different ultrasonic sensors.
And microphones for spotting for some audio gesture, information.
So you mean some emergency trucks or police trucks?
The honk of the car.
Yes. It's a great idea, but I think it's next steps for self-driving projects. When you handle everything on the road, great. You would like to add features like to know that emergency truck behind you, and you would like to get his place. Yes.
It's adjusted to every weather, like snow or rain?
You mean these sensors? So actually there are many problems with the weather. Even so, in Russia we see this problem from the first days of the project. That's why the cleaning system, how to clean system, how to so it's an issue. It's a problem. But if you have different sensors, lidars, radars, cameras, you can combine all the signals from different sensors, and it's difficult to make your car blind because the radar, for example, you have absolutely blind. It will be a problem for cameras, It's dirty, but you still have radar, or you still have LiDAR.
Okay.
Yes.
What about night vision? Because there is
For night vision, you have LiDAR and radar, and you can drive anywhere without light. So, for example, if you have algorithms which detect objects using point cloud, it's easier to detect in absolutely night pedestrian ahead of you.
How do you read the street signs?
About the street signs and other road situations, in these cases we use HD maps. About HD maps, about localization algorithms, in next talk Anton will tell us. So I will concentrate now about the hardware and quality assurance. Okay. So just a few words about the assembling. This is our last 5 cars which were assembled recently. Actually, it looks nice. Names. It's difficult to. I don't remember. So actually, I know that these wheels was Dolores has. Actually, it's tricky, but you can see that every car have this red and black stripes here, but the last car doesn't have. So I know this is Gector. So that's it. I don't remember other cars.
how many did you assemble in total?
So now our goal is to have 10 cars this year, and next year. Yeah, next year. So now I'm talking about the assembling, and we invest a lot effort to the assembling just because next year we're going to assemble 100 cars. So I definitely would like to find other names because Westworld that limits. Any ideas? Welcome. Thank you. So let's continue about assembling. So I know that guys from General Motors here, it's will be not the new things for them, but so I thought a lot. Should I do this slide here? It's just about the power, the easiest thing, just to power computer, but inside the car, it's not really easiest thing. In all demos on the conference, which I saw was there inverter inside the car. So let's think, they convert 12 volts from their car to 20 volts, and then again they convert to 20 volts to 12 volts using converter, just because everybody uses standard computers for prototyping. The problem is here is that you first of all lose energy, and it's not automotive grade thing inverter. So it's really, so actually it's a problem. That's why I just would like to say that nowadays there are many special equipment to connect your computing power inside the car, and you can use this. It's really great. Another great thing which we found, it's about the cooling this kind of a lot of computing power. So air cooling doesn't work inside the car, even in Russia, even in winter. So in Russia, average temperature -10 in winter, but even if you turn on the air conditioning, it's a problem for QA engineer to be inside the car if you have 3 GPUs and a lot of power. So water cooling is great. So no worries about the water inside the car. Use water cooling. So, what we found out else, it's when you would like to assemble pace one vehicle per day, it's really important to outsource something, for example, manufacturing mountings, manufacturing wirings outside, and then assemble it inside your company. Then you will save a lot of time to find out where is the problem with the wiring, or why this sensor just changed the position because of the bad construction of the mounting. So, and another thing, all the cars which you assemble, you have to implement quality assurance process to check everything which made even in the hardware. It's really important. Yeah, and let's continue about the QA and the deployment. The problem is here when you deploy just software, for example, web service, you go to the server, change the file, and all the users can see this file. You see the new version of your website. It doesn't work here. It's when you would like to test your car inside the city, actually there are some more procedures which you have to do. So it's easiest way to show our procedures. And so when the feature development before the city, we have to check everything which we can on the computer. So we would like to check, we would like to do testing, for example, unit testing, to check everything in simulator, to check everything on our test facility Polygon in Russia. Check performance in only after that, only after these 4 things go to and try this feature in the city. So, and another interesting thing which we found out, so for now, self-driving cars doesn't have production, so you're not deployed for millions of users. But it's a great idea to show the progress. And for example, in our team, every Friday we organize demo for our colleagues and show the progress, how it works, and just drive in the city and show the progress.
Correct?
Yes?
On the simulator, they use hardware in the loop.
About the simulator, I'll talk a little bit later. So, simulation. So, the goal for the simulator is to have the same problems which you will find in real world, in virtual world. In virtual world, we can drive millions of kilometers per day, and so we would like to have the same physical models of the car, the same things which are happening around, perception, the same things which happened with, for example, GNSS localization if you use, different behaviors of pedestrians, other cars. So here you can see how so our simulator works. On the right, it's a simulator which receive commands from our pipeline and do everything which the real car will do in real streets.
Do you simulate the weather?
For now, we don't simulate weather. We think that the most important thing which we would like to test here, this is motion planning algorithms and behavioral layer algorithms. But in the future, we will continue to develop our simulator. It will be connect features like perception, LiDAR, different weather conditions, maybe even cameras, but it's a problem. It's not so
So what you simulate the 3D scene, not the sensor data. You do not simulate sensor data, you simulate, the algorithm is presented to complete 3D scene, correct?
here you can see only so without sensors, only how car behave after we send commands to this car. But
No, actually, we simulate both. We can simulate 3D scene or sensors information. The question is how to simulate representative. What is easier to make relevant scene with noise of 3D boxes or relevant sensor information, and it's a quite hard task. So we experiment with both approaches. Right here you can see scene representation, which is extracted from simulator.
okay,
How do you measure your performance?
it will be the last slide of this
By
presentation.
people killed in the simulator.
No, we have metrics.
Only real life.
So in the previous slide I showed that performance test is really important. Here I would like to show that we track all the performance, all the things which are happening inside the car. For example, how the sensors works. This is the messages from the radar. So we see here that the frequency doesn't change. The next thing, if we found a problem with performance, we developed tools, internal tools to compare two different drives. For example, we know that 1 month ago it was pretty good performance, but now something changed and something went wrong. We can compare two rides and found their place where performance changed. So really easy and important. And another important thing from our infrastructure, so we have hundreds of different components. So you receive information from sensors, then you detect and detect this information. Then you know what's happening around you. Then you planning your route. So everything you would like to show on visualization, just for the software developers to find where is the problem. And the best thing of this tool that it works in browser, so you can open even planchette or even the tablet or phone and looks what's happening inside the car. Okay, so if everything goes well on other tests, yes.
What are the polygon tests? What is the polygon?
So-
Testing ground. So it's closed for polygon. I mean, we mean it's basically test. Like we got a huge piece of land where we build like test city where we simulate all these situations before going out to public roads, doing it in a closed kind of show.
Okay.
You're talking about many systems here. Do you integrate third parties in this solution or
Most of them are internal development. Most of the tools we developed inside the Yandex.
So software mostly done internally. Hardware, of course, we buy third-party components and integrate it in-house.
Can I ask what hardware do you use for the sensors?
Lidars from Velodyne,
As of now, we're experimenting with
radars,
others.
so we're experimenting with
What about radars?
Continental.
Continental.
No, actually, sensors are a really hard theme. So we experimenting. We try to experiment with any new sensor we know. So it's just one of configuration which Pavel showed you, but actually we have other configuration and our sensors and lidars and radars.
Yes, so our current fit is by no means is already production fit, so we're trying to figure out the best sensor configuration, the best sensor vendors, so that's why what we have right now works for us at the current stage of our development, but obviously we will continue to experiment and try every new sensor which comes out.
So yes, it's definitely not the strong recommendation goes by Continental Riders. It's not the advertisement. So it's just what we found out for us for now that works well.
It works for the moment, and will work for some time. But we'll definitely try other technologies.
Yes, question.
What's your roadmap for production? I mean, is there some kind of schedule? Because it's like a more research project.
That's a question for you, I think.
Yeah. So, well,
What was the question? I'm sorry.
the question was about what's our roadmap for production. So obviously we have an ultimate goal to replace human driver within the car. To get there, there are several barriers. Some of them are administrative, some of them are technological. By technological, we mean that there's obviously a challenge of encapsulating the compute power we need within the envelope which is suitable for automotive industry, like strict automotive industry certification requirements. And that's one of the technological challenges we think which would basically be solved within the next 2 to 3 years. So if we're talking about like making a ready product for that. The other is basically a legislation and administrative kind of roadblocks, some red tape we're facing specifically in Russia that happened. That said, with the current development platform, we are ready to provide experimental rides on semi-closed territories. By semi-closed territories, I mean like student campuses or scientific research institution campuses, or like plants where they have kind of closed territory where there is a traffic, there are people, but it's not entirely open road, and they have their own limited number of routes, and also and they have a certain administrative power to allow driverless vehicle in this territory. So for those territories, with our current state of technology, we are capable of providing the transportation services for whoever is agreed to try our technology.
You need to reach some safety regulations. Do you have?
What I'm saying, so we have very strict internal process of assuring the fact that in this territory the ride will go smooth. The proof of that is the video we just shown. We basically did exactly the same thing on our conference 3 weeks ago. We delivered a public rides to more than 700 people on the closed territory for quite a long time. So this is what we are ready to do now, provided we have an opportunity to create very detailed HD map of the territory and go there. But again, to move out to kind of production services anywhere around the city, there's the vehicle would have to be certified according to automotive grade standards, and compute power within within the envelope, within the case which suits those requirements is a technological problem right now, but we believe companies like NVIDIA and some others are trying to solve that issue, and it's going to be solved within 2 to 3 years according to their roadmap, at least if they follow that roadmap. The other thing is
do you plan to use GPUs?
we're not planning to use GPUs, but we believe that the same computational power in terms of teraflops and neural network performance will be achieved on something which will be designed specifically for automotive.
Have you considered FPGAs, for example?
We are considering everything.
Yeah, that's
We are waiting for computational units.
So have you tried actually running the inference on FPGAs?
Yes, we tried, but FPGAs right now is not really flexible in terms of research of new architectures and algorithms. So to move fast, GPU right now are the best option.
One question regarding the roadmap. Have you tried another kind of vehicle, kind of buses or shuttle buses?
That's a very good question. That's exactly what we. Pavel mentioned that we are working on. We have a goal that we need to bring 100 cars on the road next year.
Yep.
So we right now in the process of selecting what vehicle will be the base for that. So we're talking to quite a few automotive brands in our home country. Plus, one of the manufacturers which are based in Russia are building the platform for us right now, and it's a bus, electric bus actually. And
This makes sense because of geofencing.
Sure, yeah. I absolutely agree with you, but once the technology is there, it's not that hard. We figured out that it's not that hard to basically move from one vehicle to the other vehicle, provided the perception works and we know how to calibrate the sensors and make sure everything works together. And we believe we do, so that's why moving from one vehicle to the other, it's not a big issue. But bus, yeah, we're actually looking at the
There's
bus.
a number of examples like some construction, like Navia.
Yeah,
you probably
we
know.
know them quite well.
Oh, thank you.
Are you expecting to become tier 2?
We're expecting to become tier 1. No, I'm joking. We're obviously not looking into building kind of hardware, software, or like already building block. But we obviously, we have internal goal, which is developing technology, which we're gonna use by ourselves in our robo taxis, if we may call it this way. And we are kind of interested in licensing our technology to tier 1 who might be able to create automotive grade solution with our algorithms inside. That's kind of what we're looking at. Yeah.
We have another question.
What about communication between the car and the infrastructure?
Infrastructure is a very good question. So infrastructure. It's an interesting topic, and when we talk specifically to anybody related to government, they are talking about specific infrastructure for autonomous cars. We do not believe that autonomous cars require specific infrastructure. So, and we do not believe that somebody who relies on specific infrastructure for autonomous cars are taking this business seriously, because it feels like it's easier to create a car which is going to be capable of driving on the existing roads, rather than imagine some infrastructure and build that infrastructure. And once you build it, it will become quickly outdated because there will be another company who will create a car who is capable of driving on any roads without any specific infrastructure. So that's why I don't believe that there's that specific infrastructure for self-driving cars is required.
I asked before about communication between the cars and communication with the infrastructure.
Yeah, I understand. Communication with the infrastructure, so the car should communicate with infrastructure exactly like the driver communicates with the infrastructure. See the road signs, react to the traffic lights, which are detected by eyes or sensors or camera sensor. That's it. So we detect state of the traffic light because it's green or because it's red via the camera. No specific radio channel or whatever is required for us to detect the state of the traffic light.
Pavel, what is the current speed?
It was something about 60 kilometers, 40 and 40 kilometers, and I will show the last video with 90 kilometers, 94. Stay tuned. Yeah, about vehicle to infrastructure and vehicle to vehicle. So we would like to move fast. We believe that when you don't have any cars on the roads with this capability, we have to drive somehow. That's why, and people can drive. So we would like to teach the robot drive like human, and this is the most important thing for us. In the future, vehicle to infrastructure, vehicle to vehicle definitely will help everyone. But now we don't have this. We don't have this in Russia, but we would like to launch the service. Let's continue with the city tests. Okay, last questions.
Yeah, so what is limiting you to speed And why you cannot go more than 50 kilometers per?
Traffic rules.
No, above that. I mean, any technology challenges
We
that.
are following traffic rules. In Russia, there are no roads which, well, virtually no roads which can allow you to move faster than 90 kilometers per hour. That's why when we're driving on intercity roads, we were driving 90 kilometers per hour. There was one part which is allowing 110. We were driving 94 there. Anywhere before that, we were driving like according to the speed.
From the technical part, it will be definitely easier to driving in a fast speed if we have, for example, ladder with 200 meters. Or,
Yeah, that's what I'm asking. So basically, you showed before that your LiDAR now is limited in the range of.
yes, but we have radars, cameras. We've used this data. It works. In the future, it will be easier if we have, if we will have LiDAR with a longer distance. We will drive 200 kilometers. Yes, okay, about the requirements for our quality assurance engineers. So it's really important to test final feature in the final stage feature in the city. That's why for every quality assurance driver, they have training for 100 hours before they go to their city and test features there. We test every test. In every test, we have 2 engineers inside. That's why a driver can concentrate only on the road, not about how algorithms work. Yes, and hands on the wheel every time. This is the video from some routine tests. Great weather. It's not really often in Russia happening. But you can see that it's just general driving. It looks like general driving, not autonomously, because this guy on the left is just handing the wheel and just driving. Actually, it's autonomous driving. We control everything when robot drive the car, and if something bad happening, we can control in the second change control. For some reasons, this is the same intersection. So this is just a routine test, and our quality engineers control everything. So let's continue. This test are not the results. So you can see how car navigates in the city. You have some disengagements when we take control of the car. And one of the most important things, like in every project, in self-driving also, you have to analyze all the data which you get from the roads. That's why we have some internal tools where we can see all the rides, the map of this ride, everything which we get, so logs, video, and our quality assurance engineers can annotate these logs after the rides. And for example, if we found out that something went wrong, we create an issue, and it will be so when software developers can see what's happening.
They have the capability to connect and intercept driving from remote, like another providers.
No. So actually remote control.
Like a Tesla, for example. They have autopilot, they have a remote support.
I think remote support for Tesla is when you connect to the car and you just see what's happening inside the computing system, inside the software. You can
They
see
can
the logs.
intercept controls.
It's a security issue.
So we can't control the car remotely. It's no, for some reasons we don't do these things because it's not safe to control remote I don't know, from office, for example. But in the future, we think that these cars will navigate in the city with some kind of remote control feature, because you don't have driver, and if something emergent happened, you just push red button, remote engineer connects and solve, for example, this road issue, and then you continue driving autonomously. Here, when we're talking about the test in the city with our quality assurance engineers, you can't connect to the car. It's not safe. So this is the tool, analytic tool, and definitely you need to calculate some metrics. You deploy some features, and you would like to know how it affects your quality. Actually, we have dozens of metrics. The most important of them, autonomous kilometers here, and how many disengagements we have per kilometer. So we also so we calculate it every day and track it. And at the end of the presentation, I would like to show our last test drive. It's not published yet. So actually, it's 800 kilometers between Moscow and Kazan. So 1 day drive for 12 hours. It was 99% autonomously. So
the situation when the wheel was taken, when there were roadworks, big potholes on the road, which happens in Russia.
And McDonald's.
And McDonald's, yeah. For a few reasons to basically take control. Because car is not hungry, safety driver is, that's
hungry. So this guy every time is hungry.
Yeah, so but other than that, 800 kilometers worked well.
This is the moment with 90 kilometers per hour. 93, yeah.
Are you capable to replay a track from a real road in a regression test in the lab?
Yes, sure, okay, sure.
Everything, every sensor data is recorded, logged, and replayed.
Yeah, and I would like to clarify. So we are concentrating actually on city driving, on busy roads of Moscow, and we from the first days of our testing, it was the Moscow roads, and we are thinking about the urban environment. This thing, it's just happening, and we did it just in a few weeks, just to transfer one car from one location to another. We thought, so we're a self-driving company, we have to do this autonomously. So it's drove autonomously. So that's it. I'm ready to answer for the questions. No questions. Yes.
Are you guys going to keep importing or taking your hardware from other companies? Are you guys importing LiDAR from other companies, or are you eventually develop that yourselves, in your LiDAR tech and all that, for your cars?
So we're a software company. If I understood the question, we're not developing hardware. We're great in software. Yandex is a machine learning company, so we have search engine, we have advertisement, everything about the machine learning. That's why we think that our experience, the main thing where we're experienced, it's software. We have a lot of great engineers, so that's why we develop software, not the hardware. Yes?
How do you measure the number and the quality of the driving besides number of disengagements?
Good question, actually. Do you have an answer?
No, actually we have some KPIs for almost each component of our system. So it's quite obvious for perception, for example, detection quality. It's not quite obvious for tracking, prediction, and motion planning, but still we have KPIs for each component. And a hard question
how these KPIs correspond to our final KPI for disengagement, but we have a lot history of measuring search engine performance at our company. So there are online KPIs and offline KPIs. For example, you can measure user experience. It's something similar to disengagements. And you can measure something offline, the quality of search. And we have hypothesis that better quality of search, we have better online, a lot more clicks or something like this. And so similar hierarchy of KPIs we have for our project. We are open to changing everything, and our goal to safety and robustness. So it's. I hope I answer your question about quality measurement.
So yeah. So first of all, of course, it's disengagement, and we consider disengagement virtually every time the driver has to take the wheel. But besides that, we also record like every ride is annotated with the facts like it wasn't smooth enough, or we brake too hard before the pedestrians, or we don't brake too hard in front of pedestrians. So basically, there are some. So every situation is annotated. So if disengagement happens, it's not just basically recorded as disengagement. It's obviously we record the reason for that, what happened, what went wrong, whether it wasn't the obstacle or pedestrian or the car wasn't detected, or the detection was wrong, or the reaction to that detection was wrong, or the path planner did something which we didn't expect, or the localization was correct. So basically, every reason for disengagement is being recorded and investigated and improved in the next release. So that's why, of course, the main KPI is the number of disengagements, but besides that, we also measure what's kind of subjective impression of the ride. So if the ride is smooth, if it starts smoothly, if it brakes smoothly, if nothing draws the attention of the passenger, like something went wrong here, that means it's all been good. But again, if something goes not very good, it's annotated, it's recorded, and it's fixed.
Did you have any accidents?
No, not here.
Thank you.
Even scratch, no scratch.
I think we're going to stop here. Okay, thank you, Pavel, very much.
Thank you. I've warned the Yandex team that we Israelis, we have a lot of questions. So I think you did a good job. Please continue doing that. With our next speaker, just before our pizza break, we have our, as I said, our little surprise for today. If you guys are in the process of getting into the business of data science, you should know that I think that by now we are convinced that Yandex are very serious about data science, and starting now, Yandex are also very serious about data science in Israel with a special program that Miriam from the Israeli team at Yandex is now going to present. So.